The first question asks to convert the radian measure to degree measure. The radian measure is 1.8. You know to convert the radian measure to degree measure by multiplying 1.8 and 1 pi over 180. So when you multiply 1.8 in radians over 1 times pi over 180, you get 324 degrees over pi, with the final answer of 103.13 degrees, and that is the first answer. In the second question, a circle has a radius of 6 inches. Find the area of the sector of the circle with a central angle of 30 degrees. So we know to use the equation of the sector is equal to radius times alpha. So, the angle. We don't know the sector, so we'll leave that there. Is equal to the radius is 6 times, we know that 30 degrees on the unit circle is also pi over 6. So, we know that multiplying 6 times pi over 6, you end up with 6 pi over 6. So your answer is, the sector is pi. And in the third question, the third question is, a Ferris wheel has a diameter of 148 feet. If the wheel makes one revolution in 20 minutes, find the linear speed at the edge of the wheel in feet per minute. You know, since that you're looking for the linear speed, that your equation will be the linear speed, which is v, is equal to the radius of the angle in radians over the time. We know that the diameter is 148 feet. When you divide 148 feet by 2, that gives you 74. That 74 feet is your radians. So now you know to multiply 74 feet by 2 pi, which is one revolution on the unit circle, over the 20 minutes that we were given. And that will give you 23.25 feet per minute. In the next question, we must state the amplitude, the range, and the period of each function. So the equation is y is equal to negative 2 over 3 sine of 4x. The amplitude can never be negative, so it will be 2 over 3. Our range will be from negative 2 over 3 to positive 2 over 3. And our period will be pi over 2, because our period is 2 pi over 4. When you simplify it, it gives you pi over 2. The next question is, find the smallest positive angle coterminal with negative 185 degrees. In order to find the smallest positive angle coterminal with the negative 185 degrees, we must add 360. By adding 360 to the negative 185, we get 175. So now we know that the answer is 175 degrees. State the quadrant for the terminal side of the angle given is question number 6. State the quadrant for terminal side of the angle given is question number 6. Sine of the angle greater than 0 and tangent of the angle less than 0. So we know that sine of the angle greater than 0 is going to be positive, and tangent of it will be less than 0. So we know by looking on our graph where our sine, all cosine, tangent. So we know that the sine will be positive, and sine is always positive in the second and in the first quadrant. In the first and second quadrant, tangent will be positive in the second quadrant. So now we know that our answer is the second quadrant. The next one is cosine of the angle is less than 0 and the tangent of the angle is greater than 0. So we know that the cosine of the angle is less than 0, so it will be negative, and the tangent of the angle will be greater than 0, so it will be positive. So now we know that by looking at our quadrants with the sine, all, the cosine and tangent, that we're looking for a negative cosine, which is in the second quadrant and also in the third quadrant. And we need a positive tangent. So we know that that will be in the third quadrant as well. So our answer is the third quadrant. Now I must graph one cycle of the cotangent of x. We know that our asymptotes is 0 and pi. So we first make the asymptotes of 0 and pi. Now we know that as getting as closely as possible to the graph and reaching in the center, that we have our cotangent graph. Now we must graph one cycle of the function is equal to 2 sine of x plus pi over 2 minus 1. First, we can graph the sine graph. Sine starts at the origin, so now we know that our first point will be 0. Our next point at pi over 2 will be at 1. Will be at pi over 2 and 1. Our next point at pi will be back on the origin. Our next point at 3 pi over 2 will be at negative 1. And our point at 2 pi will be back on the origin. And that will be one cycle of the sine graph. But now we must stretch the graph so that way our amplitude is in the graph. So now we know that the graph will be at 2 and negative 2. Now by stretching the graph, we know that we must also move over pi over 2 units. Pi over 2 units, which is just 1 unit over. So now our units will be at negative pi over 2 and 0, 0 and 2, pi over 2 and 0, pi and negative 2, and 3 pi over 2 and 0. Now that we moved it pi over 2 units and it is stretched to 2 and negative 2, we must now decide to, and it moves, since pi over 2 is positive, it moves to the left. Now we must decide whether it goes up or down, which is decided by the negative 1. Since it is negative 1, we are moving down 1 unit. So now the graph starts at 1. So by the graph starting at 1, our first point on the graph, which is negative pi over 2, it will be negative pi over 2 and negative 1. Our next point will be 0 and 1. Our pi over 2 will be pi over 2 and negative 1, pi and negative 3, and our final point will be 3 pi over 2 and negative 1. And that will be our final graph. Now for the now to determine points from the unit circle. It says the secant of 7 pi over 6. So we go to the unit circle. We know that the secant is 1 over cosine. So we go to the unit circle and we look for 7 pi over 6. We look for our cosine, which is the square root of 3 over the negative square root of 3 over 2. So now we know to flip it for it to be 2 over the square root of 3. And that is our answer. Now for the cotangent of negative pi. We know that since it is negative, we have to go counterclockwise to make it negative. And since it is cotangent, it must be flipped. So, because negative 1 and 0 cannot be defined, it is undefined. When 0 is in your denominator, it is undefined. And also we have cosecant of pi over 3. We know that cosecant is 1 over sine. So we look at our pi over 3 and we go to our sine, which is the square root of 3 over 2. So now we know our answer is 2 over square root of 3. And our final problem is the cosine of negative 225 degrees. So, we know that our negative 225 degrees must go backwards, must go counterclockwise. So, in order to easily figure this out, I just simply add 360 to the negative 225 to get our angle. And by doing this, we get 135. So now we know our angle is 135. And now since we know that our angle is 135, looking for the cosine will be negative square root 2 over 2, and that will be our answer. And these are my corrections for the test 1.